We are taking R.D. Sharma solution, class 12th, chapter 7, adjoint and inverse of a matrix. Exercise is 7.1. In this question, we have already seen a question like this: a cube equals a inverse. So what we have to do here is, first of all, we have to compute the a squared. You take a, multiply it with a, so there will be a matrix multiplication. So once you are done with the multiplication, see, a square, when you multiply it again with a, you have to do it and show it. That is, whatever result is there, a square, if you multiplied it with a, the result will be identity matrix. Since the matrix is identity matrix, a square multiplied by something is equal to identity matrix. So when you multiply this a square with a and you get an identity matrix, that simply means this a square is nothing but a inverse. Then only a inverse into a will be equal to identity matrix, right? This is how it will be proved. Now next one is solve the matrix equation, and this kind of questions are coming, that is the different questions which we are dealing with. Many of the questions are like this, so you have to understand it very carefully. This is a 2 by 2 matrix X, and we have two matrix other than this X matrix, but we have to find out this X. So let us assume this first matrix as A, this second matrix as B. So how do we write this? A into X equals B, all in capitals because they all are matrix. Now if you multiply this with A inverse, what do you get? You multiply both sides by A inverse. A inverse and multiplied by A is identity matrix. So identity multiplied by any matrix, that will be same matrix, and right hand side it will be A inverse B. So you have to compute the inverse of first matrix A and then multiply it with B. So there is a very shortcut method. This is 5 4 1 1. Let us compute the A inverse. Exchange this 5 and 1. The diagonal elements you have to exchange. And then you have to change the sign of other remaining elements. So 1 and 5 you have exchanged, and 1 and 4 I am changing the sign. And this is the inverse. This is a shorthand trick of computing the inverse. So just exchange the diagonal values and then just take the negative of other values and put it. So this is A inverse. See, you are free to do it by cofactor method only, but I'm just going to tell you, or I'm just telling you the shortcut method. So now you have this A inverse with you. Now you have to multiply this with B. This B, so this will be, this B will be 1, minus 2, 1 and 3. Okay, so let us multiply this row with column. So 1 into 1 plus minus 4 into 1. So 1 minus 4, 1 into minus 2 and minus 4 into 3, 12. Minus 1 into 1, minus 1, 5 into 1 is 5, plus 5. Minus 1 into minus 2 is 2, and 5 3s are 15. So what do you get? This is, the first one is negative 3, this is negative 14, 5 minus 1 is 4, and 2 plus 15 is 17. So this is your X. Now all the questions are like this only because there are questions following which have the same kind of logic. So assume this to be A, this to be B, so X into A equals B. We have to find out X. So now you can multiply A inverse on the right hand side, that is X into A multiplied with A inverse, here also B into A inverse. So A into A inverse will be what? It is going to be identity element, and identity element multiplied by X will give you X only, and this B and A inverse. So let us take B here, 14777, and A inverse is how to find out? Exchange the diagonal element, so minus 2, 5, and just change the sign of the other two elements. So I am changing the sign, and thus you have to multiply this. I hope you will be able to multiply this. This is going to come. So the final answer will be this one, 3 1 1 minus 2. Now find the matrix X for which. Here we have three matrices which are already given. One matrix X need to be found out. So previously we saw for two matrix and we have to find out the other one. Here 3 matrices are given, we have to find out x. So assume it to be A, B, C. So what will be the final expression? A x b equals C. So first thing is, first we have to eliminate A and B from the left hand side, and that will come on the right hand side. So multiply both sides by A inverse, like this. A inverse into A will be identity element. Identity xb equals A inverse C. Now let us multiply both sides on the right hand side by B inverse. So multiplying it by B inverse. So this B inverse is going to be identity again. So identity multiplied by any element will return the same element or same matrix. So I and x will give you x only. This is the property we discussed already. And on the right hand side we have A inverse, C and B inverse. So x is equal to A inverse. A inverse is what? Just exchange these two. 5 here, 3 here, and change the sign of 2 and 7. Minus 2, minus 7. This is your A inverse. How about C? This is going to be C is 2, negative 1, 0 and 4. And what about B? See B. So B inverse will be exchange these minus 1, 1 and change the sign of minus 2 and 1. So this will be 2 and this will be minus 1. Okay, let us multiply these 3 now. I hope you will be able to multiply. Multiply two of them, multiply the result with the third one, and let me tell you the final result, that is going to be minus 16, 3, 24 and minus 5. This is your final answer. Now exactly same question like this. So there is no difference, only the numbers are different, the values are different. And as I said, you can use the shortcut method to find out the inverse, or you can use the long method, that is the cofactor method. This question we have already done in the past because we are already at 34th question. So we have already done this kind of question, but still I will give you a recall. So this A inverse need to be computed, and for that we need to see whether this determinant of A is available or not. Determinant of A, that is you have to find out the determinant of A, and that should come as non-zero value. If it comes to 5, for example in this case, then we can say that the determinant of A is not equal to 0, A is invertible. How about this? A square minus 4A minus 5I. So now you have to multiply this all by, see, this is 1 0 0 0 0 0 1 0 0 0 1. This is identity matrix. So A square you already know. You have to multiply A with A. Then you have to put A multiplied with 4 and then multiply this identity matrix with 5. So this is going to be 0. When you compute this is just a recall, okay? We have already done this question. So A square minus 4A minus 5I, this is going to come as 0, which you see here in the solution also. But now we have to multiply both sides by A inverse because we have to find out the A inverse. So 0 multiplied by anything is going to be 0. So A inverse, multiply this. So A inverse multiplied by A square is A minus 4 into A inverse is I. Minus 5 A inverse I is going to be A inverse. Anything multiplied by I is going to give you the same thing. So it will be A inverse. Now we have to compute this 5A inverse. So 5A inverse is going to be A minus 4I. And I hope A is already there. 4 into I already showed you. So it will be 4, 4, 4 here. And just subtract. Simple subtraction you have to do. And divide it by 5. Because this is 5A inverse. And that is going to be your final answer, 1 by 5. Okay, this question already we have seen, but I'll give you a hint here. If you are, you have not done that question, or you might not be able to recall. So AB inverse is nothing but B inverse into A inverse. AB inverse is equal to B inverse A inverse. So what is A inverse? This one. What is A inverse is already given. B inverse you have to find out. So B inverse, B is already given to you. Take the cofactors, then take the transpose of that cofactor matrix, and then divide it by the determinant of this B. Determinant of B is 1, let me tell you. And just multiply these two matrices and you will get the final answer as AB inverse. This is A transpose inverse. So there is a property which we discussed earlier, and this A transpose inverse is nothing but this is equal to A inverse transverse or transpose. So first we will find out the A inverse, and then whatever the result is, we will take the transpose of it. Okay, so A inverse is nothing but adjoint of A divided by the determinant of A. What is the adjoint of A? You already know how to find out cofactor matrix, and then you have to divide it by the determinant. That you can find out. And then A inverse, once you have computed, you just have to take the transpose of it. So I am just saying that A inverse you are able to find out. Then you just have to change the row to column, which I am showing you. This row to column, row to column. And that is going to be your final answer. Next one, A is there. So first thing is you have to find out the adjoint of A. Then you have to find out the determinant of A. That is the only thing you have to find out and put it in the equation. But we have to find out first the adjoint, because adjoint will be used in this equation also. Adjoint is simply you take all the values, try to find out the cofactor of those values, and once you have computed the cofactor, you have to take the transfers. That will be the adjoint. For example, let me tell you this, just recalling it, because we have already done this question, but this type of question. But let us say we need to find out the cofactor of C11. So minus 1 to the power 1 plus 1. And whichever is remaining, the row and column of C11 needs to be forgotten. Only 1, minus 2, and minus 2, 1 will be there. So minus 1 to the power 2 is positive, and this is 1, minus become plus. This becomes, no, it will be minus. So plus and minus, 1 minus 4 is minus 3. So this is how you have to find out all the cofactors, take the cofactor matrix, and they take the transpose. And the transpose is going to be your adjoint. So once you are done with this part, that is the adjoint you have computed, now determinant also you have to compute. Determinant is what? Easy, this is 3 by 3 matrix. You can easily compute. You can open it with any row or column. So once this is done, then A is already there with you. You have to multiply with the adjoint A. Adjoint A we have just computed, and this will be equal to determinant of A into I3. Why? Because the result will be, you see the diagonal has 27. So once you take the 27 outside, it will be identity matrix. So this 27 is nothing but the determinant of A. So you can easily say that A into adjoint A is equal to determinant of A into I3. That is your final result. Now this question, again the same thing. A inverse we have to find out, and A inverse you have to show that A inverse is equal to this expression. So A is there, A inverse is adjoint A by A, take the cofactor matrix, take the transpose. Once you take the transpose, divide it by the determinant of A. And once this is done, then you have to find out A square. That is, you have to, A square, whatever is A square, leave it. Now multiply this A with A. Now keep this A square here. Subtract it with 3 into I3. I3 is what? Diagonal will be 1, 1, 1. That is 3 by 3 matrix. Diagonal will be 1 by 1. Other values will be 0. Now, just subtract these two and divide it, means multiply it by half. That is, you are actually dividing it by 2. So whatever is the result, you will see that once you compute it, it is going to be exactly equal to the A inverse. Okay, this is your final. There is no trick, there is no logic. This is just simply computation. That's why you can have a look and observe the result. Okay, this is all about this discussion. Thank you so much. Take care of yourself.